Hi, I'm Connor Van Hoven, representing Team 21 and T&T Tools Mighty Probe Handle Alignment Inspection Device. T&T Tools has requested a quality inspection device to measure the angle offset of the threaded inserts in their Mighty Probe handles to determine if the handles can be sent to consumers. The current process provides no part quality data and can be made more efficient. The constraints and specs of this device are as shown here on the right. As for the constraints, the angles of the Mighty Probe threaded inserts cannot exceed 2.05 degrees from perpendicular, otherwise the part will be considered a failure. Also, the cycle time must be 30 seconds or less to be adequate with T&T Tools' current process or faster. As for the specifications of the device, the footprint must fit in a 4 by 3 foot area to not take up too much space on the plant floor. Also, information from the device must be displayed using an HMI screen to let the operator know what measurements are being taken and if the parts are failed. Also, a pass-fail light will be implemented on the HMI to let the operator know that there is a bad or good part present. Also, this device must store 100 measurements so that the engineers at T&T Tools can do statistical analysis on the measurements taken. Also, finally, gauge R&R will be performed to test the device's repeatability. As for the fail condition of this device, we calculated that by using T&T Tools' current process. Currently, they thread a 42-inch long steel shaft onto their Mighty Probe handles and measure the deflection using a 1.5-inch diameter target. And if it exceeds that 1.5-inch diameter, it is considered a failed part. So using simple trigonometry, we found that 2.05 degrees was the maximum fail angle. As for the sold cycle time, it is very operator involved and leaves a lot of room for improvement. And like I said before, the new device must have a cycle time of less than 30 seconds. And this video will play on the right, demonstrating what T&T Tools' current process is. As you can see, very operator involved and leaves room for improvement. So for our final design, we went with a very flat aluminum plate with other flat aluminum tabs sticking out of it for the Mighty Probe handle to sit on. And the Mighty Probe handle is stuck to the device using a Stanko clamp. And to record the measurements, we went with a dual axis inclinometer that can read both the angle offset in the X and Y directions by simply tilting it. Also, to record measurements and store them and calculate all the angles, a Allen Bradley Micro 820 was enlisted to do all the computing, and a Panel View 800 was used to control the device and display measurements to the operator. The specs we met by the design are as follows. We went with a 2.5 foot by 2.5 foot table so that the area encompassed by the device is not over the area specified and does not take up too much room. Also, as for the information being displayed, we did satisfy that by using a Panel View 800 HMI screen that shows all the angles being measured and the previous angles and anything the operator would need. Also, the pass-fail indicator is on the HMI as well that will determine if there's a bad part present after a measurement is taken. And as for the engineers, this PLC does store 100 measurements and can be offloaded onto a computer for future analysis. Now on to the test phase. As for the test phase, the two tests we did conduct were for cycle time and accuracy. As for the cycle time, after conducting multiple tests, the fastest time we recorded was 8 seconds, which is 4 seconds faster than the best operator at T&T Tools and much faster than the 30 seconds required by the specifications. And here is Nam performing the test. As you can see, this process is much less involved and much quicker than the previous process. As for the accuracy of the measurements were found to the 100th of a degree as advertised by the inclinometer specs, which does help T&T Tools help pass parts at a higher precision and accuracy, which is a big improvement. As for the challenges we faced during this design, we had to design around tight tolerances because the angle we needed to measure was so small. So any little bit of tolerance ate up our measurements. So we had to be very precise. The next challenge was waiting for electrical equipment. We were quoted that our PLC and HMI screen were going to be here in June during our design phase. However, that was not the case. And we ended up getting all our electrical equipment in the second week of July. So we had to work very, very fast. Another challenge we did face was another minute problem, but some of our parts we asked to be manufactured were manufactured incorrectly, and we had to do slight modifications to make them work. Nothing major, but just a little headache. Another challenge we did face was ordering unnecessary parts. We did order a couple wrong sensors and they had to be returned. However, they were able to be returned and did not eat up our budget. The last and most scary challenge we did face was losing communication with the PLC. This happened because the PLC serial IP address kept changing randomly and we were unable to find it. But we did combat that and we set a static IP address using SD card and we were able to talk to it again. But that's our project. Thank you for listening and I hope you enjoyed it.